Welcome and good morning to everyone. I'm really happy to see so many people here. I wasn't expecting that. Today we'll be, on this last day of EclipseCon, we will be talking about harmonizing payloads with Eclipse Vorto. And Eclipse Vorto is probably a little bit of an unknown project, so I hope I can give you some insights into what Vorto does and how it works and how this new method of mapping, this new feature of payload mapping can help you with your projects. My name is Tim, and I'm doing a lot of open source, so I was really lucky to help out and work with the Bosch Software Innovations Vorto team in Singapore for the last half a year. And I will share these slides later on, so I have some links in there if you want to click them about documentation and videos. I will post them at Timmy Grossman on Twitter. And before we go in and talk about this more special topic about payload mapping, we want to get a little insight into what Vorto is and why we need something like Vorto. So the problem with the current state of the IoT infrastructure, the IoT environment, is that there is no de facto standard defined by some global community, which means that even though we have similar ideas about how things should work, we have different manufacturers and different vendors that provide different kind of payloads, different device formats to some platforms in our case. And this increases the effort for implementation of solutions, of platforms enormously, which is quite cost intensive, right? If we look at the little schema on this right hand side, so in this case we only have two different cameras from different vendors. One is Bosch and the other one is Sony. But if we want to have them integrated in our solution, we need to do some extra effort in order to make them available on the IoT platform through like a combined interface. And then we still have the two different formats for the different devices, different payloads. What Eclipse Vorto does in this case is it provides this interface to normalize and semantically normalize and harmonize this device payload, so you have a normalized API for which you can integrate your solutions from. This in fact means that you don't have to do a lot of overhead on your solution if you follow the guidelines of Vorto. What Vorto also brings for your project is that it has a sophisticated model management environment, which is called the Vorto repository, in which you can upload, manage, and modify your device information models. We will look into what that is in a second here. And those information models provide just a very abstract definition of what your device, the capabilities of your device are. In addition to that, since we have this very abstract view on these devices after we created the models, we can use some model exporters, plugins, and everything that is provided by Vorto to generate different kind of things. In our case, this might be code stubs for integration code, which we'll also look at in a minute or two, and other things like JSON schema formats. What is pretty new at the moment is that we also published a middleware service, and this middleware service helps you do the mapping. It shows you like what kind of input you get from the devices and what it is mapped to. And it gives you just a little bit more information on how everything works. And we also provide this mapping service in general, which does the mapping, so you can set it up yourself. We have extensive documentation on that. And again, if we look at the picture on the right-hand side, we can see that we have two cameras again, but in this case, we only have one channel of communication to our solution, which is normalized through this Vorto semantic API. And even if we would add more cameras to the bottom from different vendors and different manufacturers, this would only mean that we have to do very little effort to also normalize this payload to the Vorto payload. To get a little bit more information of this, what a Vorto information model is and what this Vorto language is, we want to look at this overview quickly look at this overview. It might seem a little bit technical for now, but we only want to focus on those three elements of it. An information model is basically just a digital twin. So it describes all the capabilities of your device. For example, let's take one of those cameras or this Bosch XDK, which has different sensors like humidity, temperature, gyroscope, acceleration, and so on. You can name them. So this information model represents a whole digital twin. Function blocks can be used inside those information models, and the function blocks are the blocks that abstract away the capabilities themselves. So in this case, we might think about temperature, humidity, rain, and stuff like that. So they can be reused in different information models, and that's one of the core things you have to think about. So you have different devices, different information models, but all those information models, they use the same function blocks, which makes them very comparable. Then we have the properties, and properties just define a single element of those capabilities. So for example, we have a current measured value for the temperature, we have a max measured value for the temperature, and maybe a unit value, so if we want to have Fahrenheit or Celsius, right? We also have events and operations. Those are a little bit less used, but just to make sure you understand that they are there. Events can, for example, be used to send events from the device, like an error state, to a consumer, and operations just describe a function that can be performed on the device, on the digital twin, basically. Switching over to why mappings are interesting and good. Many of you can probably think about why you want to use mappings, because you want to have this very normalized structure, so you don't have to have a lot of overhead if you want to go into a solution. So what we did in Singapore was to showcase it a little bit better and make it more grabbable, more graspable for people and customers, is we went in and did a rapid prototyping pipeline where we can show the customers, okay, here's a digital here's your device. We can create a definition from it, an information model. And then we take this information model, we use the generators that are provided by Vorto, so you can quickly generate code for that specific device, send data, data is stored in another service, for example, Ditto, and then you can instantly see it in the dashboard displayed in the normalized format. You will see this in a second as well. This defined interface, we've talked about it before, is just really having this uniqueness, this normalized semantic abstraction that tells, okay, we can use different devices with different payloads, but still have the same structure defined. One for our approach, and the compatibility is ensured through, again, this normalized API, so you can use different devices, even swap out devices, as long as you have information models for them. If we look a little bit more at what we did with this demo here, and also getting a little bit more into architecture. So Hono and Ditto, Eclipse Hono and Eclipse Ditto should be known a little bit. So Hono is basically abstracting away the protocol layer. Hono is giving you this interface with which you can connect with LoRaWAN, HTTP, MQTT, depends on what you want to do. So we can just connect every single device with Hono, and then the data is sent to our middleware. And this middleware is the element that does the mapping, as we said. It gets the information, what has to be mapped and how it has to be mapped from the Vorto repository, and then we can send or push this data to some platform, some consumer, like Ditto in general. We can use AWS or IoT things, like we did. And this is the very abstract overview of this, and let's look at an actual use case example, so this gets a little bit more clear what we are doing and why we're doing that. So let's assume we have this customer, and he wants to have monitoring for his greenhouse. He wants to have capabilities like temperature, humidity, irradiance, CO2 maybe, and the brightness for his plants in his greenhouse. What we can then do if we use Vorto is we can simply go in and quickly develop a prototype that just uses like a Raspberry Pi or any other element like this, plug in some quite cheap sensors or sensors that are laying around, depends on what you want to do, just to get a really quick feeling for what you're doing. And we can then describe this model, in this case the Raspberry Pi, with the sensors, with an information model. And then use the Vorto infrastructure again to really out of the box generate everything. And I will quickly switch over to the Vorto repository, so you can see how one of those information models might look like. So in this case, this is the example for this greenhouse prototype. And here we can see the definition in the Vorto language. So we have defined some metadata, like what Vorto language is used, the namespace of it, and what is displayed. And we also have this part about the imports. And those are the function blocks. So every using defines what function block is used. And we will see this later on when we progress in this prototype to product phase. Below that you can see the information model, and the information is then model is then assembled with these different function blocks. As you might also can see, it's still a very abstract view on this device, on this information model. What we can then use this for is, if we go up, we have these official plugins and experimental plugins here. And these plugins are basically toolkits, toolboxes that allow you to do different things. Like, for example, generate different code stubs for different languages. So, for example, Java, Arduino C, or Python. You can also use the device provisioning API of, for example, Bosch IT Suite to quickly create a digital twin for that device, set up everything in Bono, in the hub adapter. So you can very quickly prototype all of that together and make some data going through the whole process, making it visible to the customer. So in no time you should have a prototype, an example on how that whole thing could look like. And you can already start with developing, for example, a dashboard that shows actual data to your customer, since after the whole process, after we went through the middleware, we already have this normalized semantic API. And that is what won't change in the process when you change the devices or the integration of the devices. If we then, for example, take a look at the MQTT Python part, you will get something like this. And this is basically a completely filled Python program, and everything is already set up for you. You have all the mappings for the function blocks that are defined in the information model, of course. And if you scroll down a little bit further, the only thing you have to do here in order to make it work is fill out the device configuration that you get if you provision your device. And then there is one part that says begin reading sensor data. And it even gives you a whole setup of every single function block and every single value. So the only thing you have to do here is fill out those values with the sensor data you read out with the Python program and just run it. And then it sends the data to the MQTT broker that is defined in the configuration on top, and it then pipes it through the whole process. Switch back to the presentation. And this is something we can also do several times. So in the end, we want to have a sophisticated product for the customer, right? We want to have something that is usable, that is maybe also applicable to other customers. So what we will do in the process, of course, is we will change what products we use, what sensors we use, because we want to have the best outcome possible. So maybe we do an iteration with the Arduino. We use more sophisticated sensors, and we change the language from Python and MQTT, to C and use Bluetooth, because we want to have a gateway in our greenhouse instead of having every single device send the data to the cloud right away. So we want to have a gateway, and then the gateway sends it to the cloud. In the end, we might want to have a finished product, or we will have a finished product, and in the process we might also change the protocol again. In this case, the blind tag, it uses LoRaWAN. For example, we discovered that we don't only want to have one single greenhouse, but we have a whole area of greenhouses, and we don't want to have a gateway in every single greenhouse. We want to have a centralized gateway to which all the sensors can connect, and then this gateway sends all the data to the cloud. And LoRaWAN is one of the technologies that is exactly developed for low-powered devices and long-range distances from the sensors to the gateway. And the good part is, if you look at the information model for the Plantech now, it's basically looking exactly the same as the prototype, right? We didn't change something about the capabilities, because in the beginning, you normally define the capabilities with your customer. What do they want? And since we have all the function blocks already defined, we can just reuse them in the Plantech. So the information model looks nearly the same, which means that the Vorto, the normalized semantic Vorto representation, will also look the same in the end. And this is really what makes this whole project so powerful, because you can have different devices that are completely not alike and still have the same API in the end. Switch over to the next one. Okay, taking this architectural drawing we saw before and moving it to a little bit more actual implementation like we did it, we still see the same approach. We see Hono, this time it's used in IoT Hub, Bosch IoT Hub. We see Eclipse Vorto, the middleware in the middle, and we see the Ditto, which in this time is using IoT things. The process is exactly the same. So we have our two devices, our Raspberry Pi. We won't look at the Arduino for now, and the final product. So prototype and product. And they both send the data to IoT Hub, which is powered by Hono, in their device-specific format. So you don't do anything for until that point. Hono then moves the data, the device-specific payload, to Eclipse Vorto, and Eclipse Vorto maps it to this normalized API. And in the end, what we get in IoT things, in the Ditto area, in the Ditto abstraction, we get the normalized information. And since we have these information models defined, the data for the prototype and the product will basically look the same. The values will be different, but the structure should be the same because we use the same function block. So what we can do is we can easily develop an application, a dashboard, whatever, that reads this data from things, from Ditto, and then displays it in the dashboard. And again, to point this out, the first level, the Hono level, abstracts away the protocols. So we have the first abstraction is for the protocol, so we don't need to write our own protocol layer for each device, for each protocol technology. And then Eclipse Vorto abstracts away the data, basically. So it makes the data, it harmonizes the data. To show you this a little bit better, I will give you a quick look at what we were developing with the dashboard in this mapping software. And that's why I will switch over to the dashboard here. So in this case, we have this application you just saw a screenshot from, and we have different devices in there. And all of those devices are already moved or forwarded through the mapping engine, through this middleware. And here we can see we have the prototype and we have the Plantech. And they are created with their serial numbers. And down here, we can also see that we have different widgets already defined for different function blocks. So the customer or the integrator doesn't even have to create his own widgets, because those are normalized for each function block. The structure, again, the structure always looks the same. So we can easily say, okay, we create a new widget for the humidity, which is a percentage value, instantly display this specific widget for that element. So if we create a new device, we can see the widgets right away without doing any more effort. What we can also look at here is the Plantech, and if you can see, again, it's the exact same amount of widgets, it's the exact same widgets, just with different values in this case, because it's two different devices, still the same values. To make this a little bit more intuitive for potential users or customers, we have integrated this simulate tab here. And this simulate tab also just gives the same insights I just gave you with this greenhouse example, but with two different devices, a Tracy tag and an electric motor. And the process is the same, IT hub, middleware things, and then to the dashboard. And here we can start the simulation as a user. And once this simulation is running, this takes a few seconds to start. There we go, it runs. Then we can see the electric motor and the trucks, the Tracy tags, are being run and simulated. And then we can also see the values change here, as well as in the greenhouse prototype and the blend tag elements. Just to give a little bit of an insight into how everything works and what the user can see here. What we can also observe is switch over to the second element, which is the mapping middleware. We also have another dashboard that a user can use or the integrator can use to debug, which is this brick console, which shows you all the inputs that are coming in and being mapped in the middleware. So you can instantly see all the elements that are coming in, which is really helpful. And this is one of the services that are currently provided by the Vorto team, just for testing out. You can set it up yourself if you're interested. We are currently working on like a Dockerized version, so you can quickly deploy it. And the other thing is that we have really extensive documentation on all the different things I'm showing you here, how to set it up, how to customize it, how to use it, how to really integrate it with your own system. One really interesting thing about this mapping engine is that we can easily also, you can see here, Ditto is running. We have this normalized JSON Vorto Ditto format, but we can also output other formats from this mapping engine. We just need a specification for it. So for example, there is AWS IoT, there is Azure IoT. So what we can do here is we can just activate Azure IoT, AWS IoT, and connect to those exposed endpoints, and we instantly get the same information we get for the Vorto Ditto, JSON Ditto, for AWS IoT, so we can instantly integrate an application with AWS IoT or Azure IoT. And this is easily extensible for different kind of platforms. Back to the presentation. Let's see. Maybe the question now is, how does this middle layer work? How does it work that it maps everything? What you can do is you can use the mapping editor in the Vorto repository for each information model. You can access the mapping editor when you click on the create mapping. I can show you this in a second. And then you get to this nice overview. So you have all the function blocks that have to be mapped on the top left side. And you have a condition, some properties, and you can even add custom converters, which is basically just JavaScript, so you can do quite interesting calculation as well if you have to do some more advanced stuff. What you can do is you can paste in your example payload in JSON, in CSV, in binary, in this top editor here, and then define your mappings with the status properties, the conditions, and if you do test mapping, you can instantly see the feedback down here, where the mapped format is then displayed. If there is any problem with your mapping, it instantly says, okay, this mapping is not correct, fix it, because this and this part is not correct. It even says, okay, we are expecting a long value, and you're just giving us an int value, for example. Or we are expecting float value, but this is an integer. And again, you can see canonical, AWS IoT, Eclipse Ditto. There you can also already see all the different formats that are currently being supported, that can currently be mapped. And as I said, you can also just extend this if you want to. How this works is that you can, if you see it over here, you can, for example, define if our payload, if our incoming payload, device-specific payload, does not have any carbon dioxide definition, we don't map it. And if it has, we just use XPath values to extract the different values like current measured, max measured, min measured, and you can even set constants like, okay, carbon dioxide always is measured in ppm, so we just set a fixed value there. One of the things I've found to be really interesting about ONO is that you have the possibility to provide default values. So you just provide a default element, and what the mapping engine in this case relies on is that this is given. Otherwise the elements cannot be mapped. What this also means is that you have to have an information model, of course, and you have to know the content type that devices are sending. So the device-specific payload has to be defined in some format, for example, JSON, binary, CSV, depends on what the device is sending. And then you define the content type here. You put in the whole definition of this specific information model. And if you're creating this device in the device registry in this way, the Vorto mapping engine exactly knows what to do with the device payload, given that there is also a mapping specification added to the mapping engine. All right, so as I said, I will post the slides later, and we have a lot of really interesting links in here. For example, our blog post article about the payload mapping in general, which also links to the big information, the big documentation about how to set this up, how it works internally, what you can do with it, what you cannot do with it. And then we have different guides, and also what I just described with this customer who really wants to quickly prototype something, have something displayed in a dashboard, show some values. We also have that as in a video about 30 minutes. And that's it from my side, and I would be really interested in questions from you and what your ideas are, and if you have any questions in general. Okay, so the question is what the internals of the mapping engine look like. Okay, the mapping engine itself is a custom-written Java program, but it's very generic. So it uses what I just showed, the mapping specification, in combination with this definition of the device and the content type, and then just applies some conversion to each of the fields that are coming in. And there are different mappers integrated at the moment, for example, JSON and CSV. And in there you have to define, so you have, if you want to add a new converter, if you have a different kind of content type, you add a new converter to the repository. That's a way you can contribute to the project as well, to the Widgets project. And there you can define, for example, okay, I'm sending, let's say, binary, then you just do a binary decoding, and then you also assign the values given this mapping specification. But it's very little, so it's very, the code base is very abstract and very nice, so you just have to do the decoding part, and then everything is handled by the mapping engine. But if you need more information on that, we can also talk later, and then you can also get information from the project lead who can help you out with that as well. Any other questions about the payload mapping, Vorto in general? Cool. All right. If you're interested, you can also talk to him.